Hello, welcome to Maths with EJD. In this video, I'll be talking about using binomial expansions in calculus. One of the beauties of binomial expansion is that it can help us to simplify calculus, talking about differentiation and integration. So let's go straight to it and look at differentiation, for instance. Because I have a whole playlist on differentiation. You can check that out. It's comprehensive, covering, uh, on calculus, in fact, covering both differentiation and integration. So generally, right, if you're given 1 plus x raised power n. Strictly this, please. In case the value, if 1 becomes 2 or x becomes 2x, you can no longer use this idea. So you can follow the playlist on calculus to actually know all the rules. But generally speaking, if you have 1 plus x raised power n, we can actually differentiate term by term. We can differentiate, we can differentiate term by term. So what that simply means is that if you have d dx of 1 plus x raised to power n, that's simply normal differentiation thing now. Bring down the power n and multiply by the original expression with power n reduced by 1. So here you have this to be n into 1 plus x raised by n minus 1. So if you use the usual technique of substituting and saying let u be 1 plus x and all that, you're going to get exactly the same thing. So once the format is 1 plus x like this, you can actually follow it through. So if you take an example to buttress that fact, you have this. So if you need to differentiate 1 plus x raised to power 3. So 1 plus x raised to power 3, that simply means you have d dx of 1 plus x raised to power 3. And that means bring down the power 3, and then the original thing, 1 plus x raised to power 3, but the power reduced by 1. That's the idea of differentiation. And this is now 3 into 1 plus x all squared. So the normal method the normal way would have been to say let u be 1 plus x and do all of that. But if as far as it is 1 plus x raised power whatever, you can go that way. And that is it for um differentiation. Can we switch to integration and also see how that plays out? Integration. So here, the binomial expansion, the binomial expansion can also be integrated term by term. So you can integrate it, and also be integrated term by term. Okay. In that case, imagine that you have integral of 1 plus x raised to power n dx, and that is equal to, so here, of course, you know the idea of integration, right? Increase the power by 1 and divide by the new power in case you don't know. So that's 1 plus x. So this n now becomes n plus 1, and then you divide by the new power 1 plus x. I mean n plus 1, right? So the power you started with n. So when you integrate, the power increases by 1, and then you divide by the new power. And of course, here you need an arbitrary constant to make up for whatever you might have lost in transit, so to speak. So, and of course, this only holds for when n is not equal to minus 1, because when n is minus 1, that whole thing breaks down. So using this idea now, we can take an example. Say you have, in fact, what we had, we had 1 plus x. We differentiated that when we got this. Can we integrate exactly the same thing and see if we are going to get back 1 plus x raised to power 3? So here now we have integral of 3 into 1 plus x raised to power 2. So of course, that's the same thing as 3, because 3 is constant. Integral 3 integral of 1 plus x raised to power 2. Of course, that should be with dx now, dx. And this is 3 out here times 1 plus x raised to power 2 plus 1 divided by 2 plus 1. Usually, you should substitute and do all of those things. But as far as you're guaranteed that you have 1 plus x in brackets, you can freely do this. So you have 3 times 1 plus x raised to power 3 all over 2 plus 1, that's 3. So 3 cancels 3. And then the whole thing is 1 plus x raised to power 3. Of course, I mean, since we just have to put we need always need to put this arbitrary constant. But because we know where we are coming from, we already know that c is equal to 0. So that's one thing with that. So you see, at the end of the day, we have recovered what we got. So you see, binomial expansion can really help in this interesting way. Right, so I'm going to stop here. Subscribe to this channel, hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know how helpful these videos are for you. And of course, let me know if there's a topic you like me to teach or a problem you like me to solve. Then like and share so that more people can have access to this. But before I go, let me give you some questions to practice. Okay. Practice questions. 1. Differentiate. 1 plus v. 1 plus v raised to power minus 7 with respect to v. 2. Integrate. 1 plus p raised to power 5 raised to power 5 with respect to p. All right, so that's it. See you. Have a great time.